Without further ado, James Wall, the floor is yours.
Thank you so much for that kind introduction. Can everyone hear okay with the mic? Perfect, sounds good. What an honor to be here. I think what i4Kids is doing is amazing, and I thank the entire leadership team, and specifically Sophia and Cindy, who helped me organize this talk and come to Barcelona. I think the mission of the organization is so aligned with what we've been trying to do that I'm happy to be here, and I'm happy to share our experience. The name of the talk is Lessons from Us, and that word has two meanings. It's U.S. We are a U.S., United States-based program. We're out of Stanford University, and I'll talk a little bit about that. But us, the group that's doing it, really think globally. I'm originally from London, and our current Pediatric Biodesign Fellow, Elizabeth, who's here in the front, fifth row, is from none other than Barcelona. So we think globally, and we're really happy to come here and speak and think about ways to collaborate. So I'm going to start with what I generally start with when I talk about pediatric innovation. There is a shocking inequity between pediatric and adult medical devices. This is a simple example that I'll show, but this is a central line for anyone in medicine. You probably know this. For the rest of you, it's basically a large catheter that goes into the bloodstream. It allows physicians to give life-saving medications. You can see in the adult world, there's a very simple and elegant solution to protect this line from infections with a sterile covering and from movement with clasps and securement devices. What do we do for our most vulnerable babies in the ICU at Stanford and here, by the way, because I was at San Juan de Dio yesterday? We use a chunk of non-sterile tape to hold their lines in place. And this is just, I use the term bonkers. I don't know how well that translates. It's crazy. It's nuts that we don't have a better solution. So this is one example. It's a story. But to share data and back that story, this is FDA approvals that we analyzed of medical devices between 2008 and 2016. And what you see here is when we really broke down between adult devices, the blue line, robust growth, increasing approvals by the FDA, and devices that were truly designed and tested in children, meaning growing children, babies, that truly have unique diseases of childhood, the numbers are shocking, right? Maximum of 5 approvals in 2012, 0 approvals in 2013, and really just a flat line of very few pediatric devices. And again, kids are a fourth of our population, probably about the same here. It doesn't make sense. So who are we to do something about it? Well, just as a little bit further background, I do help run the Biodesign Innovation Program at Stanford. That program has a 20-year track record of teaching a repeatable process of innovation for healthcare and practicing that technique. It's resulted in almost 60 startups that have gone on to acquisitions and companies. And ultimately, though, the devices that have come out of our program have touched, now this number's from last year, but now it's up to about 8 million patients. So pretty impressive, except not enough have helped children. And so a group of us, including myself as a pediatric surgeon, colleagues in pediatric urology and neonatology, who have the training, who have been physician entrepreneurs, but who also feel the pain that there's not enough devices for us, we've come together and really tried to focus on pediatric innovation. So, how did we start? Well, we started by an analysis that it sounds like you went through last year. We know these things exist, but we wanted to come up with better strategies to address them. There are significant issues in developing devices for children, there's no doubt about that. And the fundamental question we asked ourselves is, how do we develop high-impact technologies for small markets that can be scaled with a sustainable business model? And we among other things, ran into the same issues highlighted in this forum last year. Funding's challenging because this is generally small markets and doesn't often allow for venture capital type returns. There's technical challenges when you talk about developing devices that may have to treat different sizes of children or grow with the children. There's regulatory risk that goes along with this, as well as liability, which is a significant challenge in the US. And then when you get into adolescence, there's issues around privacy and other things. So we sort of broke down these issues and said, how can we use our biodesign process but consider these issues? This process, I won't go into detail. If those of you who have seen it, it really is all about identifying unmet clinical needs and really making sure that you've defined the opportunity before you invent a solution and that you're really going to have a positive potential impact on healthcare, and then really coming up with a detailed plan to implement. If you haven't seen this, I recommend the Biodesign textbook, which is really a roadmap for anyone interested in healthcare innovation. So the first thing we did about almost 10 years ago now is say, okay, if we're going to try and do pediatric innovation, we better be sure that we can do it ourselves before we start saying we're going to go around the world and or even just outside the walls of Stanford to help others. So we started with that first observation I showed you that came from some students, the total difference between how lines are secured for adults and for babies. And we went through our design process, beginning with making sure that that was a real problem. I'll talk about that later, but we identified that there was real costs to higher infection rates, there was real costs to those lines moving out of place, and we felt that it was a real opportunity to provide outcome benefit and value to the healthcare system. So with that in mind, we started going through the invention process. We were initially, I don't have a laser here, but in the top right of this, on this side, you can see we were initially inspired by the top of a baby bottle and just having kind of a see-through cone that we could use to secure the line, protect it, hold it in place. There was a unique challenge in that the lines from the baby come straight out and they're in the umbilical cord, which is a piece of tissue that needs to dry out and die over the first week of life. So with those challenges in mind, we worked with the nurses, went through the prototyping process, and ultimately did much of the testing we needed to do within the university. We used grant funding to really advance this project as far as we could. We did bacterial testing to find the optimal design. By doing that, understood that there was a patent and intellectual property around the airflow because that was critical. We could protect it with a dome, but we had to allow for airflow to dry out the umbilical cord. We then did mechanical testing to show that we could really secure the line and prevent motion 2 to 3 times more than the existing taping systems or other devices on the market. So we put in the work, ultimately came up with a device that looks close to this. This is a little bit of a rendering. But fast forward to today, we were able to commercially launch this with a small investment, which I'll talk about in a little bit. The company is generating revenue, and they're approaching making enough money to sustain themselves, which is really always the model we wanted to prove could work. It's been on over 2,000 babies and counting, and their initial clinical studies have shown really massive reductions in line motion. So I share this story to just say that we felt like we had to prove, again, we could do it first before trying to then teach it and potentially fund others to do it. The good news is lightning didn't just strike once. I won't go into these other projects in as much detail, but these are other Stanford faculty projects that were focused on pediatrics, adolescents, and that have successfully gone on to commercialize. And actually these last two have both been acquired by larger companies and are both commercial successes as well as high-impact products. The second one here is from Janine Furch, who's one of my colleagues in the pediatric group. She's a neonatologist, but when she was a biodesign fellow, her and her team identified the unmet need of unwanted pregnancies while taking oral contraceptive pills. And they noticed particularly in the adolescent population that there was they were both digital natives and a desire for having information at their fingertips around use of oral contraception. So for example, if they were to miss their pill for one day, to immediately know the risk of pregnancy and whether they should take 2 pills, etc. That type of information packaged in a digital system with a smart pill box was their solution. That went on again to commercialization and acquisition. The next one came from one of our pediatric cardiologists who identified a real need around tracking asthma. Her insight was that the current system for asthma monitoring really relied on a piece of paper and parents writing down the symptoms of their children. That system just wasn't utilized very commonly, as you can imagine. And they really took that information, they added sensors into the bed, they looked at respiratory patterns, they looked at symptoms through an app, and were able to show in a study that they did that by integrating these sensors and having a really easy interface, they could decrease hospitalizations by identifying when asthma was getting worse and having those patients treated before they ended up in the hospital. And this project went on to be acquired by Apple, who has a lot of interest in sleep, but we're not sure what they're going to do with it yet because they're quite secretive, as you know, or may not know, but they're quite secretive. So we proved we could do it once. We proved we could do it a couple times with some successful outcomes. Then we got ambitious. then we said, all right, we want to be a global leader in pediatric health technology. I don't know if we're there yet, but at least we had kind of this bold vision that we really do want to do this. We want to go outside the walls of Stanford initially, and then outside the walls of the United States. And really the way we do it, and I'll share this in the next few slides, is that we really focus on education and enabling pediatric entrepreneurs. And we think that that's the way to get to scalable solutions. So in terms of, that was kind of the story. Now I'm going to go into the lessons. The first one, I'll just lay out how we built our program for what it's worth. It's not the only way to do it, but I think it's one lesson in how we approach building the ecosystem, not just individual projects or companies. So we start with education. Again, the Biodesign Fellowship has about 20 years of history. It's mostly focused on adult solutions in the past, but it's a wonderful process to learn. I acknowledge that D-Health here in Barcelona has done a fantastic job of teaching a very similar process. So we're not unique by any means, but we do have a long history. And so one of the first things I was able to do was get funding to make sure that we had at least one pediatric or maternal provider each year who was in the program, or someone with an interest in pediatrics. So we were able to get funding to specifically support a pediatric maternal trainee. So it really begins with educating people. And again, you've got a great opportunity here in Barcelona and others around Europe. I can't acknowledge them all because there's so many biodesign programs now. It's just wonderful. The second thing we really thought about was what resources were required and trying to match and build those resources. So we built a consortium with our neighbors, UCSF, University of California, San Francisco, another major children's hospital close to us. We fight over patients, right? We are competitive about patients. But when it comes to developing devices, we really are able to get along because it takes an entire ecosystem to do this work. We were able to get support from the FDA, which is a U.S. government organization that does have some grants in addition to their regulatory work that they do, from some foundations and some from private donors. We start with our Innovators Forum, which we held yesterday. I actually joined it because I love it so much. It was 11 p.m. here in Barcelona, but I was part of it. And our Innovators Forum is where we really invite anyone to come share ideas, and we offer 3 tiers of resources to those innovators. And the innovators can be anything from a clinician with an idea, an engineer who's seen a problem and has a solution, to companies that have products but want to bring them into pediatrics. So we invite all to this program. We often start with coaching, so people come to us and they may have a problem and an idea, but they may not fully understand what it takes to get a device through the FDA, what it takes to prototype and show initial animal data, etc. So we start with kind of coaching and really helping them develop a plan that they may be able to develop that technology. Any team that's willing to put that effort in and come up with a reasonable development plan, we can offer directed resources. And what I mean by that is spend small amounts of money on helping them build a prototype, helping them with an FDA consultant, figuring out where they have a risk, and we can spend a small amount of money to help them move forward. And then finally, seed funding, very similar to the contest that we're going to see here, and I'm very excited to see the projects. We do an annual pitch competition where we're lucky enough now to have about $500,000 in seed funding that we're able to distribute to the most promising projects that we see from around the United States. And with our most recent donors, we've been able to use some of that money to support global programs as well, global projects. And then the last thing that we are beginning to work on, and this is early days, but I think it's very important and something I think we can collaborate on with Eye for Kids is policy. The biodesign program at Stanford has committed to more work on the policy front, gathering data, showing where there's inequities in healthcare, and presenting that to our elected officials and regulatory agencies to try and make positive change and make more devices available to patients. And so we're going to leverage that program, look at things in the United States, for example, how there's been legislation around orphan drugs that has arguably at least contributed to a significant increase in the number of those drugs developed for small populations, but we don't have similar incentive schemes for medical devices. So that's one example, but there's many, many policy issues that we're going to tackle. So just to kind of summarize on program building, 3 pillars of what we do, and I think it's worth considering. Education always first in our mind, making sure that we train people who are interested in becoming entrepreneurs, give them the skill set, the toolbox to do this work. Enabling them with resources, coaching, directed resources, seed funding, and ultimately getting them in front of investors if and when the time's ready. And then finally, policy. So that's the lessons learned from our program, is to really tackle those 3 pillars of pediatric innovation. So now I'm going to go on to the results. So we started with the first project we did. That was the catheter securement. We were able to do more. Now, once we've put these 3 pillars together and we've been able to gain some funding, we currently support between 20 and 35 projects a year with those tiers of support that I shared with you. This is our results from last year. We supported 33 projects at different levels. We awarded almost $500,000 in grant funding. We launched our policy initiative. Actually, our first policy paper, we focused on the UK and the NHS because there was readily available data on payment for pediatric devices, so that paper's coming out shortly. We, as we track our impact over the last 5 years of doing these grants outside of our internal group, we've had projects that have gone on to clinical use. So far, about 18,000 patients have been positively impacted by the devices that have come out of this funding. And the companies who have gone through this process have gone on to raise about $40 million in funding to be able to commercialize and go forward. So again, showing initially we could do it internally. Now with the program that we've built, we're able to support others in doing it. So that's kind of the wrap on the program part. The last thing I want to talk about is maybe a little bit more delving into the details of the biodesign process, which I know everyone from the Eye for Kids group is very familiar with. I wanted to just highlight again a separate group of lessons here. When you're going through the process of health tech innovation, our experience is that there's a few areas in the biodesign process which, I'm a true believer. I think it's a wonderful, detailed process that can really help you increase your chances of getting a medical device to the market and positively impacting patients. But there's a couple areas where I think you really need to be very thoughtful when you're considering pediatrics or maternal. So I'm going to go through a couple of those as kind of the final lessons we've learned when it comes down to the nuts and bolts of the process, or maybe we'll call these tips and tricks. So early in the process, I think focusing on value, and I'll talk a little bit more in detail, is really important. As you start to build a plan, thinking about being very capital efficient, and by that I mean spending very little money or very little investor money early. Thinking about non-dilutive funding, grant funding to get things going is very important. Considering parents as a stakeholder, that's pretty obvious, but sometimes gets missed. Really considering whether intellectual property patents are necessary in very small markets that have low risk. And then finally, thinking about alternative sources of capital. And this is probably the one that everybody wants to think there's a magical way to fund these. It's not, it's hard, but we'll talk a little bit about that. So focusing early on value, I love this quote. I was lucky enough to work at one of the large venture capital funds in Palo Alto in order to kind of learn how that industry works. And one of the partners there, very famous, says to me one day, I invest in massive markets because I like a bullseye so big that we can afford to miss, and it's fine, we'll still make a lot of money. So it's always kind of stuck in my head that it was just such an ingrained part of their approach to investing. And so I guess I kind of adapted it when we started thinking about pediatrics and said we kind of have to have the opposite mindset, that to innovate in pediatrics, it requires a laser focus on the impact you're going to have and the value you're creating, because the bullseye is tiny, and even just to make a sustainable business, and you can't afford to miss it. So I think this is the kind of work, when we were doing the umbilical catheter project, that we put a lot of time and effort into early. This is based on a massive search of the literature, talking to physicians, but we really dug into what the complication rates were and what the costs of those complication rates were, and really had to look ourselves in the mirror and say, do we think we can have a positive impact on this? Because if we can't move the needle here, a cute device that looks nice and kind of makes sense is not going to really get to market and have value. We have to really have a positive impact. So, this is a long analysis that I won't go into a huge amount of detail, but we really felt like length of stay from infections and migrations was something we could have a positive effect on and really save money in the U.S. system, and particularly when it came to infections, which are directly correlated with migrations, and an area where within the U.S. the payers can really cut off payment to you if you've had a hospital complication such as an infection. It can really hit the bottom line of hospitals. So we felt very early on, before we invented anything, that there was real positive value to be had here. So early focus on value, I think, is really critical when you're thinking about pediatric innovation, both value in terms of cost savings, also value in terms of positive outcomes. Next is thinking about capital efficient development. This is the same project. I promise I'll use a different project in a minute for examples, but I'll stick with this one for now. When we started this, my first advice to the team, having worked at a venture capital firm, was there's no way this is investable. It's too small, it's 200,000 patients, it's maybe a $20 million market. There's nobody that's going to invest in this. Now, I changed my mind later, but that was the starting point. So when they came to me and said, we really want to do it, I said, okay, but we have to start within the university. We have to start spending as little money as possible to get answers and see if we can move this forward. So we started literally by just recruiting a few students. We early on got an $88,000 grant. We leveraged Stanford facilities. We leveraged our access to the Children's Hospital. And we made really a huge amount of progress on that. We were able to, on that amount of resources, go from prototype all the way to essentially a manufacturable device within the university. Once we had a manufacturable device with a customer ready, and all we had to do was really ship it out and put a quality system in place, We were able to get a seed investment from an angel of $100,000. In addition, we used some other resources around innovation and an accelerator. We used some local interns that we got for free. We got a government grant for an SBIR grant, which in the US is specifically focused on trying to build a business. And once all this was in place and we were ready to deliver the device to our first customer, we finally convinced an investor that there was so little risk left. We had the device ready to go, we had a customer, and we had a clinical study ready that would prove if it would work. We were able to take a small investment of $1 million and get this device all the way to commercialization on a very small amount of money. So that's part of that story, but really the point here is capital efficient development. The next lesson is considering parents as a stakeholder. This is a different company that's been part of our portfolio and network, a company that's doing vision screening for children using the iPhone. Very simple system, but a big challenge in marketing and getting the word out to pediatricians and making sure that they know it's available, how to use it, when to use it, etc. And I won't go into too much detail. I think it's relatively obvious that you should consider the parent as a stakeholder, but really thinking about how the parent can influence, really thinking about how parents can call to action and go to their pediatrician and ask for something, and even thinking about parents as potential consumers who will pay for devices. So I think early on in pediatric innovation, you always want to consider the parent-family dynamic and how to bring them in and make them advocates for what you're doing. IP strategy, this is another project that I'll briefly describe and really ask the question, do we need a patent? This is existing devices for fetal shunting. So babies in the womb that develop either an obstruction of their bladder or develop cysts in their chest can benefit from a shunt. You put a tube into that cyst or into the bladder and drain it to the amniotic fluid, and you can help either with the lung growth or trying to preserve the bladder and kidneys. This was developed in kind of the 80s and 90s. Really, no one was willing to invest in a customized system, so they used adapted adult systems that were really made for kidney disease. But anyway, there was a little bit of adaptation to be able to deliver it for fetal surgery, but because it wasn't really created for this problem, they fail about 50 to 80% of the time. They fall out of place, they migrate. They're just not really designed properly for the fetus and for growth. And what's really interesting is this middle one. I was talking to the fetal specialists here yesterday. It's not even available in Europe anymore, and I'm pretty sure it's not available in the US because the company just doesn't even want to support it. It's literally not worth their time and effort, and it's more expensive for them to continue to manufacture and have a quality system than to sell a few thousand of these a year for a very specialized indication. There's another version of the shunt that is still available, but that could go away at any minute. So our group has been working on this and have a very unique design. We've leveraged a little bit of learnings from the cardiac occlusion devices, but really what you see up here in the middle is kind of a shunt that will grow with the abdominal wall of the fetus, because the fetus does grow significantly. Clever design, it works well in initial testing, but it really raises the question, do we need a patent? If no company is even interested in supporting existing devices, do we really need to spend $100,000 or whatever? I mean, that's generally what it costs in the US to do a well-written patent. Is it worth spending that, or is it worth investing that money in trying to really build a repeatable manufacturing process and just share this with the world, because nobody's going to make a lot of money off this, and that's not the intention. The intention is to make it sustainable and something we can get to patients who need it, and again, with maybe 5,000 uses globally, IP just might not make sense. So, I'm not a patent attorney, I'm not giving you legal advice, but I think it's really something worth thinking about when you're working in the most niche or small patient populations. And then the last one, which I'll touch on, is how do you potentially fund these projects? And I think, this is what I call the innovator's equation. There's a lot of things that go into this, but if you have a sense of what your market opportunity is, so for example, the umbilical catheter we'll go back to, we thought that was about a $20 million opportunity in the US if we sold one for every catheter used. And then you subtract what it costs you to get to market, you have to be able to do one of three things, in my opinion. You have to return an investment, which is the venture capital model, and they're generally looking for, at a minimum, 4 to 5 times return. They really like the idea of 20 to 100 times return, and they like big returns in terms of absolute numbers. So for a large venture fund that has $1 billion to put $1 million into the umbilical catheter and even get 5 or 10 back, it just doesn't move the needle for them. It's too small. So, but return on investment is important to consider, because if you're going to go for that, you have to understand that there's a lot of pressure, you want to grow, and you want to find an acquirer. Now, the other option is a model that we call return of capital. There's a smaller group of people that do this, but this is kind of the idea of, some people call it venture philanthropy, some call it impact investing. There's a few groups in the US that are beginning to deploy this model specifically in pediatric healthcare. And the idea is that, again, back to that example, okay, we'll give you $1 or $2 million to develop it. 5 years later, we'd like that $1 or $2 million back, but you don't have to give us 20 times. We'd just like our money back, and we'd like to show that we have had a positive impact in addition to getting our money back. And then we'll take that money, reinvest it in the next group, and try and have an evergreen fund that is able to support but not necessarily create huge returns. And then I think the last model is what I call philanthropic investment to sustainability, and that's the groups like the Wellcome Trust, Gates Foundation, and others. Sometimes they'll be willing to give you that $1 to $2 million, and you don't have to give it back, but the expectation is that ultimately you do get to something sustainable. Right? You can't just spend the $2 million, build 20 devices or 100, and then you got to go back for more. I still think that if you want to have impact at scale, you can use philanthropic dollars to develop, but you really want that to get you to a sustainable business. Doesn't have to make a huge amount of profit, but you want it to be able to continue to generate products for kids. So with that, I'm 1 minute over, but I will say thank you. Our program is growing. We love the idea of collaborating, again, across the US and across the world. I'll be around all day, happy to chat with anyone who's interested in hearing what we're up to, but we're really excited to be part of this ecosystem. So thank you all so much.